Now we learn about momentum. So the momentum is maybe a new word for us, but now we are going to learn about momentum here. The momentum is a product, okay? So the momentum is a product of mass and velocity. So the momentum is signed with a small letter p, is the product of mass and velocity. Okay? So as we know before, that the mass is scalar. Scalar means that it only has magnitude, but it does not have direction. But the velocity has both. It has direction and also it has magnitude. Okay? So for example, when the scalar is multiplied by the vector, so the result is vector. What does it mean? It means that the momentum P is momentum. Okay. So the momentum or P is also it has direction. Okay, it has direction, or it's called a vector. Okay. The sign factor is always is also signed with the line, okay, above the letter, like that, and also like this. This means that the V is vector and P is also vector, but M mass is scalar. So the momentum P, M is mass, okay, with the unit of kilograms, and V is velocity, okay, and the unit of velocity is meter per second. Okay. So what's the unit of the momentum? The unit of momentum is the unit of mass and also the unit of velocity. The unit of mass is in kilograms. The unit of velocity is meter per second. So the unit of momentum is kilogram meter per second. Okay? So as I have taught before, that the momentum has direction, it also has magnitude, it also has value, it also has direction. Direction means going to the right. Example, going to the right. Okay, going to the right, it has positive, but going to the left, it has negative value. Okay, so remember, when an object going to the right, it has positive value, but if it's going to the left, it has negative value. Okay. Now we are going to have to look for the example, to find an example with the momentum itself. For example, is an object of, let's say, a ball, 5 kilograms ball. 5 kilograms ball is traveling to the right, but the velocity, for example, is, let's say, 5 meters per second. Okay, traveling to the right, but the velocity of 5 meters per second collide with another object, let's say 7 kilograms ball, with the velocity of 0 meters per second. The 0 means that this ball of 7 kilograms, it doesn't move at all. Okay? So I tell you that the result of the collision is that the 5 kilograms ball, is moving with the velocity v. We don't know that what we are going to solve, that what we are going to find, the velocity of the 5 kilograms ball, and I tell you that the velocity of 7 kilograms ball, let's say is 3 meters per second. Let's say it's 3 meters per second. So now we are going to solve this problem with one law, that the momentum is conserved. What does it mean, conserved? Conserved means that the momentum before the collision, this is before the collision, is equal to the momentum after the collision. Okay? Remember that the momentum is conserved. Conserved means the momentum before the collision is equal to the momentum after the collision. Before the collision, this momentum is equal to mass multiplied by velocity. So the mass is 5, the velocity is 5, so the momentum is 5 times 5. Okay? So what's the momentum of this 7 kilograms ball? The momentum of 7 kilograms ball is 0 because this is 0. Okay? So it's equal to the momentum of 5 kilograms after the collision is 5v, and the momentum is 7 kilograms is 21. 7 multiplied by 3. Okay? So this is the total number of the momentum before is equal to the total number of momentum after the collision. So 5 times 5 is 25 plus 0 is just 25 is equal to 5v plus 21. Okay? So the 5v is equal to 25 minus 21 is equal to 4. So v is equal to 4 divided by 5 is equal to 0.8 meter per second. So what does it mean? This means that the 0.8 meter per second has directions going to the right. It is not going to the left because there is no negative sign here. So the 5 kilograms ball is also going to the right with the velocity of 0.8 meter per second. So all these directions is the same directions going to the right. Before going to the right, after is also going to the right. Okay? So the 7 kilograms ball is also going to the right, as I have told you before. Okay, the second case is, I tell you that the second case is like a gun. So let's say that this is a gun, okay? A gun, a static gun, it doesn't move. So what's the velocity when an object does not move? The velocity is 0. Okay, so the gun with the bullet here. Okay, so what's the momentum of this gun when it doesn't move? We say that the momentum is 0. Okay, so this gun fired a bullet. Okay, it's fired a bullet so that the gun, the bullet moving. Okay, the bullet moving with the velocity of, let's say, 400 meters per second. Velocity of the bullet is 400 meters per second. Let's say that the mass of the bullet is, say the mass of the bullet is 0.01 kilograms or 100 grams. And let's say that the mass of this gun is 1 kilograms, and we don't know the velocity of the gun after it recoils. Okay, so now we are going to solve the velocity of the gun after it fired, the bullet. Okay, we do the same way like before. With the law of the conservation of momentum, that the collision before is equal to the collisions after. So before here is after. Before, the momentum is 0. Why 0? Because the velocity is 0. Okay? 0 is equal to what's the momentum of this gun? Is 1 multiplied by v. Plus, what's the momentum of the bullet? Is 0.01 multiplied by 400. Okay, make a bracket here. So 0 is equal to v multiplied by 0.01 multiplied by 400 is 4. So what is the v? What is the velocity of the recoil gun? Is 0 minus 4 is equal to minus 4 meter per second. What does the sign mean? What does the negative sign mean? The negative sign means that the gun is going backward. It's going backward after it recoils, after it fires. It fires the bullet. So the bullet is going to the right, but the gun is going to the left because of the force that exerted by the gun to the bullet. Okay? So the result of the velocity is minus 4 meters per second. Okay, I will conclude all what we have studied now. That an object with the mass m1 and the velocity v1, okay, let's say going to the right, collide with another object m2 with the velocity v2 and going to the right, and the result after the collision is m1, still m1, okay, with the new velocity v3 and m2 with the new velocity v4, let's say going to the right all, okay. So we conclude that the law of the conservation of the momentum is momentum before the collision, which is m1 v1 plus m2 v2 is equal to the momentum after the collision, which is m1 v3 plus m2 v4. Okay, don't remember this equation because sometimes it will very useful for us to solve another problem with the momentum, impulse, and also safe car. Okay, so next time we will study impulse with very interesting topics. Thank you.